Hello everyone. So in today's session, we'll be covering STAAD parameters. In this session, you are going to learn about how to assign steel parameters and concrete parameters for any given structure. Here, I'll be covering Indian code as well as American code. Now these are the two widely used parameter code that we are going to encounter in our industrial day-to-day life. So we'll start off with a Indian code first. So I'll be covering a steel parameters of a Indian code initially in this session. So here I have this particular table that I've extracted from STAAD help portal. Here you will be see a widely used parameter that we generally assign in our STAAD file. Now remember, these are not all the parameters, but the widely used parameters that I have covered in this particular session. So the first parameter that we are going to start with is code. In a STAAD Pro, you have to define through which particular code you want to design your structure. So we start off with the IS 800 2007. So this is must when you initially deal with a design parameter. Now let me just show you. I have this particular STAAD file that I have prepared for illustration of various steel parameters. So once I'll be explaining you each parameter in the presentation file, and then we'll move to STAAD file and we'll see how we assign those parameters side by side in our STAAD file. So this is a particular portal that I have created with the moment frame in Z direction, and it's a braced in a X direction. Along with that, I have a plan bracing that I have created over here. Property wise, all the members are currently ISMB 350, and ISA section, that's the angle section, I have used for a bracing part. Material, everything we have it as a steel. Under specification, I have assigned truss member for all the bracing members, and releases that I have created for a ordinary simply supported frame direction. Moving on to the support condition, since I have moment connection and shear connection with a bracing, I have created a pin support over here. Loading part, I have just simply considered a dead load of a structure and a live load that I have assumed in all three directions. That's a gravity load in Y direction and X and Z direction, so that we get all kind of moments in our structure. And the load combination, that is 1.2 dead load plus 1.5 times live load. Remember, these are just assumed loading, and as per the R load, we can give it to our particular structure. And we'll be moving on to a design tab. Now this is the tab where you will be assigning both steel parameters and concrete parameters. Now the structure that I have started is a steel section, so we'll move on to the steel parameter part. Under the code part, what we have just learned our presentation, that we'll be assigning a code first. So through this drop down, we have to look for an Indian code. That's over here, that's IS 800 2007. Now you can choose LSD method, that's a limit state design, and that's WS, that's working stress design. Now majority of the structure we consider limit state design, so we'll be using IS 800 2007 LSD as our main codal provision. Moving on in the presentation, we can see next parameter that we'll be assigning is beam. Now by default the value will be 1. Now let's understand what does value 0 and 1 means. So if we assign beam value 0, then the design at ends and those location specified by a section command will be designed and checked. And if we provide a value 1, so that is design at ends and every 1/12th point along the member length. So just to put it in a simple layman language, if we provide 0, then you have to specify to STAAD at which interval or at which distance from end you want your member to be checked for moment and shear and axial force. If you don't want to specify, we can use a command 1. That's what it says, that the beam will design at end for whatever moments, shear and axial force it's coming at ends. Along with that, the entire length will be broken down into 12 parts, equally length 12 parts, and at all those 12 junctions the STAAD will check for a individual design criteria. So that is the default value, that beam value 1 should be assigned to entire structure. Now it's a anyway default value, so even if you don't define the beam as 1, it will automatically take that value and design the structure. However, just to highlight how can we define the beam value, let me just show you. Under current code, we go in define parameters, and here we'll be having all applicable parameters based on IS 800 that we can assign to a structure. So these are initial parameters which are there, are based on a angle, and if we go with a RAM connection, that's an inbuilt program for a STAAD file to do the connection design. We don't have to specify this criteria or these parameters for our angle. So moving on to a beam, we'll be having 1 as a default value. So we just go add and close. So under parameter 1 tab, that's the initial parameter tagline that STAAD generate. As and when you go further, this parameter 1 can go up to n units. So under IS 800 LSD code, we have a tab that is beam 1. Now you see it shows a question mark. That means that this particular parameter is not assigned to any of the beam sections or any of the structural members. So what we can do is that we can select this parameter and we can say assign to view. So now it shows a tick mark. That means that this beam parameter 1 is assigned to an entire structure. So what basically it will do is that this particular beam will be divided into equal 12 portions, and at each junction the STAAD will check for a bending moment, shear and axial force check, and based on that it will show that the entire member is passing or failing at the end of an analysis. So that's what it was about beam parameter 1. So next in line we have a can command. So can command, we have 3 options. The default value will be 0, that defines it as a general member. The next is 1, that is applicable for a cantilever member, and the next value 2, that is for a simply supported member. Now can command is very important and can be tricky. So when do we assign cantilever portion? So when we have this particular parameter is applicable for both deflection check and also defining a limit for a bending stress as per the clause 8.2.1.2. Now if I have to show you the clause, so as per the IS 800, the clause has a this clause checks for a design bending strength as per this particular formula, and it has a limiting value that MD shall not be less than 1.2 times ZE Fy upon gamma MO in case of it's a simply supported member. So at this portion we have to assign can as a 2 wherever we are considering a simply support beam, and 1.5 times ZE Fy upon gamma MO in a cantilever beams. So wherever we have considered a cantilever which does not have any stay or any knee brace or any brace just to make its deflection under control, we have to go with a can command 1. So as I have said earlier, this will be applicable for both strength case as well as the serviceability case. So if we go in our STAAD file, let's just see how do we assign this particular parameter. So can is a 0 is general beam. So any moment connection frame like this particular member, we don't have to assign a cantilever portion as 0 as it is a by default value. Now we have to go with a value 1 and the another value is 2. So that is for a simply supported beam. So we have added that. Now in our structure, we have this particular beam, that's a cantilever beam. It does not have any stay, so it's a overhanging beam, you can say. So here we have to assign can command as 1. Now remember, this particular parameter 1 is for a strength design. We'll be creating this parameter 2, the next portion, that will be for a serviceability design. Now what is strength design and serviceability design? Serviceability is nothing but a deflection check that we perform for a STAAD file. And strength check, those are the checks that we check for a structure is being safe under a given loading. So we check for a bending, shear and axial forces. So that's a strength check. And the can command 2, that will be applicable for all the shear members or a simply supported member that we have in our STAAD file. So I have selected all the members which are simply supported beams, and I'll be assigning a parameter can 2. Right? So we are clear with this particular portion. Next in line, we have a parameter that's DFF. Now DFF, DJ1, DJ1 and DJ2 and can command. These are the 4 commands that we have for a serviceability check. So what does it simplify? DFF is a deflection length divided by maximum allowable local displacement or a deflection. So we are defining a value till how much displacement of a beam is okay with us. We have to give that particular limit to a structure. And DJ1, DJ2 is nothing but we have to give a like an initial point and an end point of a member that STAAD will consider for a deflection check. Now what I am trying to convey you over here is that take this particular beam. Now what is happening is that now this as a actual beam, it's a continuous one member, but since we have a node over here, so STAAD will not understand that since we have this releases over here that this is an entire one member. To STAAD, it is a 2 members having a length, one as 1 meter and another beam has a length of 1 meter. So we have to specify that to a STAAD that it is not a member with a length of 1 meter each, but it's an entire 2 meter length of one member. So we have to assign DJ1 and DJ2, that's a start point and a node point of a node of a structure, just so that STAAD will understand that okay, I have to consider this particular member as a full length member, is in spite of we have a node at in between. So what does code says about this deflection criteria? So let me just show you that in a table 6 we have a deflection limits defined by our code. So it is divided into 2 parts, industrial buildings and other buildings. Now let's just consider that we are considering a industrial building, and we have criteria as vertical displacement and lateral displacement. So what do we understand by vertical displacement and lateral displacement? So in STAAD file, if this particular beam with a given vertical load at top of this particular beam, this beam will try to deflect vertically something like this. So that's a vertical displacement we are talking, and not like this particular beam won't deflect in this direction. So what are the members that will displace under horizontal load? So these are our column members. So assigned with a wind load or any particular point load at top, this particular beam or a column, I'll say, will try to displace in this particular direction. So that's a lateral displacement. What do we say by lateral? That's a horizontal displacement. So as I was telling is that if we have a simply supported beam like this that we have in between our column with a vertical load, this particular displacement curve will be somewhat like this for this particular member. So this we consider as a vertical displacement. And if we consider a column with a horizontal load, this column will try to displace something like this. So this is the displacement value and this is a lateral displacement. Lateral displacement is nothing but a horizontal displacement. So if we go back in our presentation, we are having a different loading criteria. Based on that, a code is defining a DFF value, or I'll say maximum displacement value for this particular case. So we are having a live load and a simply supported span. That's all our beam members. So we have two supporting criteria, elastic and brittle cladding. We'll be considering an elastic structure. So the span divided by 240. That's the maximum displacement value, 240 for our simply supported span. And if we consider a live load and cantilever span, then the value is span by 120. So same we are going to apply in our STAAD file. So we go under a entire structure. Let me just give you entire structure, and under a design part, we have to create another parameter so that will, as I said you earlier, that will be having two parts, strength and serviceability. So can command, DFF, DJ1, DJ2 are part of a serviceability check. So we'll be having another design code. So let's just provide a check code and this particular parameter will assign to check code for the entire structure, and then we go to a DFF value. Now for simply supported, as you have seen, it was a 240, so we'll say add, and for a cantilever part we have seen the value was 120. Just to refresh it, let's just see it over here. For a simply supported beam, for elastic structure we are having L by 240, and for a cantilever with the elastic part it was L by 120. So we have provided both the values. So now we are having a parameter 2. Now this particular parameter will be restricting only for a serviceability, that's a deflection check. So we'll assign our DFF values for all the beams and cantilevers. So for a cantilever I'll be assigning DFF 120, and for rest of the beam members we'll assign DFF 240 for all those beam members. Now let's go back to our presentation and see what do we have for column members. So that was about the vertical displacement. Now we come to a lateral displacement. So when there's no crane and we are having a column members, for elastic cladding we have to restrict our displacement as 150. So another cases are crane plus wind and crane plus wind with a gantry and column frame. So since we'll be having no crane but we'll be having an impact of wind load in our structure, so we'll be considering with the elastic structure arrangement we'll be having a limit as H by 200. So the DFF value for column will be having 200. So let me again go back to a define parameter tab. You can see that still we have IS 800 2007 as our main code, even though we have changed our parameter from 1 to 2. Again I'll be going into DFF and will be having a value as 200, and I'll say add. So in DFF 200 I'll be assigning all the columns, so that's a parallel to Y, and I'll assign this particular DFF command to all the columns. So now we have the limits that how much displacement is allowed for all the structural members. Now as I've said that along with that we have to define a can command. So I'll be giving a can command again over here. I'll be assigning cantilever 1 and 2. Since we already have the member for this two parameters, so I'll just copy it from top, so it will save our time. Right, so now can 1 is assigned to a singular member, that's this, and can 2 is assigned for all the simply supported portions. Now we can move to the DJ1 and DJ2 parameters. So as I had said you earlier that like you can see this particular beam, we are having the beam is divided into two parts. So we have to assign dj1 and dj2 for this particular beam. As far as those beams which are not broken by any intermediate nodes, we don't have to assign dj1 dj2 parameters for such beams, as STAAD will automatically understand that since this is an entire one beam, so it will check the displacement for an entire this beam. But when there is an intermediate node, we have to assign that we have to tell STAAD that this is a start point and this is the end point of that particular member. So I'll say shift n so that I'll know what are the node numbers, and I'll select both the members. I'll go into define parameter, and under dj1 I have to give the initial node number, so that's 13. I'll say 13 and add. And for the same beams, I have to define dj2, that's the end node, so I have to enter 14 over here and add. So I have this dj1 13 and dj2 14. That's a start and end node of these two beams. Now I have to assign it. So I'll say assign and assign. So we are through with that. In similar fashion, we have to assign the dj1 dj2 parameters for our columns as well. Now columns will be broken since we have introduced intermediate beams everywhere. Apart from that, we are having this isolated node over here, that's a node 20, which is breaking the column. So in actual scenario, this column will be a continuous one member and it won't be broken it over here. So what we have to do is that we have to select all three members and we have to assign dj1 dj2 for this particular column members. So here the dj1 will be 1 and dj2 will be 13. In similar fashion, we have to assign to all these column members, we have to select those columns and we have to assign dj1 as 11 and dj2 as 18 for this particular column. Let me just show you for a one particular column and we can move on to a next parameter. So I'll say dj1, it's 1, I'll say assign, and dj2, that's 13, so I'll say 13 and assign. Since I have already selected this member, so instead of adding those, I have simply just assigned them through the parameter tab itself. So I have this members. So this is how we assign displacement parameters for our structure. Moving on to the next parameter, that's FU and FULD. That is nothing but ultimate design strength for our steel members, and FYLD is